Okay, question number 3. Okay, so let's begin with question number 3. It's about, it says that prove true or false, justify your answer. So for this, you need to prove whether left hand side is equal to right hand side or not. So let's have a look at the first one. So first one is 10 times 10 raised to the power 11. Okay, now you know the exponential rules, right? So wherever you see this, you should know that you can apply them. You can see that the bases are equal, right? So when the base are equal, what happens then? So according to the exponent rule, when the base are same, so you add up the powers. Okay, so bases will remain same. Now here above 10, there is no power, so it means it is 1. So it is 1 plus 11 equal to 12. So left hand side is not equal to right hand side. So what do you think they might have done here? Why they wrote 100 raised to the power 11? What they would have done is that they might have multiplied the bases and kept 11 same. Okay, so again, just to test your understanding of exponents, now let's have a look at the second question. So I'm writing it over here. So 2 raised to the power 3. So how much would that be? You know that. You can just simply calculate them. It is 8, and 5 raised to the power 2 is 5 times 5. 25, super simple, right? And you know that it is false because 2 raised to the power 3 is not greater than 5 raised to the power 2. It is the other way round. This is smaller than this. Now the third question, 2 raised to the power 3 times 3 raised to the power 2. So solve it. So it is, we know that 2 raised to the power 3 is 8. We have just seen it here. And times 3 raised to the power 2 is 3 times 3. So you can directly write the answers for small questions. It is 72. Now 6 raised to the power 5 is 6 times 6 times 6 times 6 times 6. So you multiply it. So take a minute, check your calculations, what you will get. So when you'll solve it, it'll come out equal to this number. Okay. So now, what might have gone wrong? What do you think? Like what they were expecting you to think? So what they were thinking is that you will look at this. What they've done, they have multiplied the bases and added the powers, right? But we know the rules that we cannot do this, right? There are rules only in case either the base are same or exponents are same. Okay, or you change your question in such a way that you can write your you can apply your exponent rules. Now back to the question. Now question number 4, it is 3 raised to the power 0. So you know that any number raised to the power 0 is always equal to 1. So this is true. Okay, and do mention that whether they are true or false because they're asking for an answer. Okay, so here it is also false, so mention that whether true or false. Next question. Now this question is all about calculation, so you have to solve them. Okay, so let's start with the first question. So you are supposed to write them as product of prime numbers only in exponential form. So it means that you have to find the prime factors of each and every number in this slide. So it is 2 5s are 10, 2 4s. Let's do it quickly. Okay, and 192 is, it's an even number. So I'm using the 2's divisibility rule because every number is ending with an even number. Okay. Okay. Now you can write them here. I'm writing first all the prime factors of 108, and now it's turn for how many 2's are there? 1 2 3 4 5 6 2's. 1 2 3 4 5, 6, and then I have a 3 also. Okay, so now how many 2's in total? 1, 2, 3, 4, 5, 6, 7, 8. So it is equal to 2 raised to the power 8. And here it is 1, 2, 3, 4. So 3 raised to the power 4. So this is the answer. Now, second question. 270. Again, last digit is 0, 2. Remember, they are specifically asking about prime numbers. You cannot take composite number for division, okay? You have to take prime factors only. Now, last digit is 5. So, you know that divisibility rule of 5 says if any number ends with 5 or 0, it is divisible by 5. So, we'll use that property. And then, here onwards, we can use the table of 3. Okay, I'm directly writing it here. Now, 270, we can write as 2 times 5 times 3 times 3 times 3. So, it is 2 ones, 5 ones, and 3 how many times? 3 times. Now, let's have a look at the third part. 729 first. Okay. In case you are not sure, apply divisibility rules. 2 not possible. What is the divisibility rule of 3? 3 says that if you add up all the digits and the sum is divisible by 3, you can divide that number by 3. Divisible means there is no remainder. Okay. So 7 plus 2 makes 9. 9 plus 9 is 18. And 18 is divisible by 3. So we can divide this number by 3. So let's check that if our assumption is true. Yes. Again, 4 plus 2 is 6 plus 3, 9. So we can divide by 3. Now 81 we know for sure it is divisible. And then here comes the table of 3 again. Okay, so how many 3's do we see in this? I'm writing it here. So I'm directly writing it in the power form. 1, 2, 3, 4, 5, 6. 3 raised to the power 6. Now let's try for 64. So it is 2, 32, 16, 8, 2 fours, 2 ones. So it is how many 2's? 1, 2, 3, 4, 5. That's the answer. Now let's check the last part. 768. Even number divisible by 2. Okay, 2 ones are 2. 9, 2. 9s are 18. 2, 6. Now this is 2 3's. No, not 3, sorry. 2 4's are. So 2 4's are 8 here. So 1 carry over. So 2 8's are. Then 2 2's, 2 4's. Then 2 12. 2 6. 2 3's. And then 3 at the end. So we can write 768 as how many 2's? Let's count 1, 2, 3, 4, 5, 6, 7, 8. 2 raised to the power 8 times 3 because 3 is there and only 1 3 is there. So we leave it there. So did you analyze? Did you just see? Notice that we have got such big numbers, right? We're finding the product. But even the product and those numbers are just made with these two prime numbers. Isn't it amazing to know just that you can create so many numbers with just a number 2 and 3? Wow. Okay. So let's move to next question now. Okay, now it's a simplification question. Again, application of your rules of exponents. So let's write it down. So this is 2. I can see the product of product rule. Okay, so a reminder, what is product of product rule? That when you multiply, when you have power of power, then you multiply the powers. So here we will multiply 5 and 2. So we will get 10 and then 7 raised to the power 3. Now, do you notice that here we have this 8. 8 is a composite number. So break it down as as in terms of a prime number or the numbers which you see in the question. So I see a 2. Is it possible to break down as a product of 2 or something with 2? So let's see. Yes, I can write it as 2 raised to the power 3. Okay, so I wrote it. But I have written 8 as 2 raised to the power 3. So remember that there is a 3 outside which you have to keep as it is. Okay, you haven't solved it yet. So it will be 2 raised to the power 10 times 7 raised to the power 3. And here 2 raised to the power, multiply the powers again. 3 3s are 9 times 7. Now you'll solve it. Uh, these numbers are in division, so apply the subtraction rule. So 2 raised to the power 10 minus 9 here, and here it is 7 raised to the power 3 minus 1. No power means 1. Then solve them. So you'll get 2 times 7 raised to the power 2. Easy, isn't it? Okay, next. Now let's have a look at the second question. 25 times 5 raised to the power 2 times t raised to the power 8 over 10 raised to the power 3 times t raised to the power 4. Okay, now again, I see prime number also and composite number also. Remember to break down all the composite number into prime numbers. It'll make your life easy. So let's try. We know that 25 we can write as 5 times 5. You do not have to show the factorization here. You can just directly substitute the values. I am writing it here to show you what we are doing. So 25 I can write as 5 raised to the power 2 times 5 raised to the power 2 times t raised to the power 8. Now I'm substituting the value of 10 as 2 times 5 and 3 overall times t raised to the power 4. Now let's combine these two because the bases are same, and let's solve for t also. So there are many things that I'm solving at the same time. Pay attention please. So it is 2 plus 2 here, and t become 8 minus 4 because I have this part. It is in division. It will go to the numerator. Powers will get subtracted. And here, I hope you notice that these two numbers are in product and there's a common power. So we'll break it down. We write it as 3 and here also 3. Okay. Remember that I can do it with this part. But can I do it with this? No, you cannot do it with this. Okay. These exponential rules are only for product or division. Now let's solve it further. We get here 4, we get here 4, and we get here 2 raised to the power 3 and 5 raised to the power 3. Now you see that we have got 5 in numerator and denominator. I'm showing you how to solve it further then. And then equal to 5 t raised to the power 4 over 2 raised to the power 3. That's your answer. Okay. Now let's have a look at the last part, third question. So it is 3 raised to the power 5 times 10 raised to the power 5 times 25 over 5 raised to the power 7, 6 raised to the power 5. Again, convert all your composite into primes, okay? So 3 is a prime, will not touch it, but 5 is 5 times 2, 10. 10 is 5 raised to the power 2. Sorry, 10 is 5 times 2 and power 5 is outside the bracket. Then 25 is 5 raised to the power 2. Then it will remain as it is, and 6 we can write as 2 times 3. Okay. Now open all the brackets first. Which rule are we applying here? We are applying that if you have two numbers being multiplied and the power is outside the bracket, a common power, then the power gets distributed. Okay, distributed means you get a copy of that power. So here this, and here this, and here this, and denominator also we will solve. Okay, now combine all the like ones. So all of the terms with the same base I'm going to combine. So let me just first check 3. So I have here 3 raised to the power 5 and 3 raised to the power 5. Let me solve them up first. Let me even, highlight all the like ones. So I have these 3 terms with 5 here, and then I have got these 2 with the 2. So that's all then. So let me combine the 5s here. Even I can just cancel them out. Do you notice that their powers are same? I don't have to write it. Now what about 5? Can we cancel something? So now, well, I do see for 2 raised to the power 5 and 2 raised to the power 5, they are also cancelled. I see here I have got 5 raised to the power 5 plus 2, and then I have got 7 in denominator, which I'm bringing to the numerator. So I will get 5 plus 2 is 7, 7 minus 7 0, and I'll get 1. Now, you would have noticed that this 5 raised to the power 5 and 2, if you add them up, you will get 7. And then 7 was in the denominator. So from here itself, also you could have cancelled them out. But again, if you feel that you might make some mistake, then stick to the method of solving step by step. So this was the last exercise of 11.2, and that's it. Now the next exercise is on the standard form, the scientific notation also we call it. So we will be working on the standard form in 11.3. Now let's have a look at that, what kind of question come. First let's see what is the standard form of numbers. A standard form, see, you have learned about the numbers, right, and different type of form, expanded form, this and that, right? But then the chapter we started off with, or this chapter is usually, in this chapter you learn about or talk about the large distances, huge numbers, which are very difficult to write on a paper, right? So to make it easy, we teach the standard form of numbers. Now let us learn what is the standard form. So you see it is this number 15, right? So I can write this number as, isn't it? Because 10 raised to the power 0 is equal to 1, so I can write it as this. Or maybe it has come from 15 times 1, and then you can write it like this. Now, um, and this number I can write as 15 times 10 because there is 1 0. This I can write as 15 times 100 because there were 2 zeros, right? But then what is happening? We are writing our numbers in terms of zeros. What happens when you do not have zeros, or when you have a decimal like this? Is this a standard form? No, this is not the standard form. In every standard form, you will have a number, okay, and a decimal also. And the decimal is always placed after the first number, after the first digit. Like 15 becomes 1.5. But 15 is not equal to 1.5. So how do we solve the situation? How do we cope up with the situation? So what do? We think of that, how many decimal places we have got now. We've got one decimal place, and one decimal place means out of 10. So we multiply it by 10, or 10 raised to the power 1. Okay, when you solve it, what you will get? 1.5 into times 10 will give you 15, isn't it? So this is our standard form. Now let's have a look at the second one. So we will not write 15 times 10. This is still not the standard form. We need a 10 for sure. But we will write 1.5. Okay. And then you have got a 0 also there, right? I'm taking it directly from here. Okay. Now in this, now again 150 is not same as 1.50. So what do? What do is we multiply this by 10. But how many? What will be the power? Now count your decimal places, 2 places. So the power will become 2, or you can see that we have gone to hundredths place in decimal. So we write it power 2, which again represents a hundredths place. Just to ensure that we are getting it, I am erasing it because this doesn't make sense now. Because when we talk about the standard form, it means that I need a decimal here. Okay, and then whatever numbers you are writing, you will write it like this, as it is. Then by which number should we multiply? So 10 raised to the power, again I have 3 decimal places, I'll multiply it by 3. Last part, 159.3. So I already have a decimal. So what do? We bring this decimal again to the place where I need it to be, and the same procedure. Just multiply by 10 raised to the power 3 because I have 3 decimal places. Okay. So always remember that, we always say that when there is no decimal, the decimal is at the end. Okay, so you don't have to get scared looking at the position of a decimal in a number. So let's begin the questions based on this exercise. So write the following numbers in the expanded forms. Now they are asking you to write these numbers in the expanded forms. Expanded forms are, I'll just show you one example and I want you to try this yourself. Just check the places, you know how we used to do it, ones, tens, or just look at the places. You have two, okay, times. Now how many, what is the place value of this two? So ones, tens, 100,000, 10,000, 100,000 or lakh. So 2 times 1 lakh or 100,000. Okay. Now we do not write numbers like this. Okay. In expanded form now, especially we have learned about this. So count how many zeros you have. 1, 2, 3, 4, 5. And based on the numbers also, we have 5 digits after 2, after 2. So we put 10 raised to the power 5. Okay. Now plus, next number is 7 into 10. Now how many digits after 7? 1, 2, 3, 4. So 4 at the top. Now next is 9. How many digits? 3 digits. Plus 4. How many digits after this? After this 2. 0 we will not write. And 4 you can write 10 raised to the power 0 because there is no number after it. Next is 300619 4. Start with the first 3 times. How many digits? 1, 2, 3, 4, 5, 6. Okay, then we will ignore the next two zeros, directly jumping to 6 times 10 raised to the power 3, 1 time 10 raised to the power 2, 9 times 10 raised to the power 1. You do not have to write 1. And plus 4, you can leave it at 4 or you can just put 10 raised to the power 0 also. 2806196. So 2 times 1, 2, 3, 4, 5, 6 again, plus 8 times 5, 10 raised to the power 5, plus 0 we will not write. So 6 times 10 raised to the power 3, plus 1 times 10 raised to the power 2, plus 9 times 10, plus 6 times 10 raised to the power 0. Okay. 120719. Let's write it down quickly. 1, 2, 3, 4, 5 plus 2 times 10 raised to the power 4. 0 we will not write. 10 raised to the power 0 plus 1 times 10 plus 9 times 10 raised to the power 0. And the last one. I think we have become expert in this by now. 4 and 8. Okay, that's it. Easy. Okay, let's move to the next one. Okay, now this is expanded and we are doing the reverse of what we have done earlier. So what will be the first number? So see that you have got 8 places. Okay, I'll just rewrite this. So 8, and then I have 4 places after this. So 1, 2, 3, 4. I feel more comfortable when I draw these lines because I know that how many digits I have after that. Now next is 6, and then 6 has 3 digits afterwards, so 6 will come here. Then 0 times 2, so 0 will be filled here. Then 4 and then 5. This will be 4, and then I have got 1, 2, 3, 4, 5 places to fill. Now 5 is coming. See, there is no 10 raised to the power 4, right? So we place a 0 there. Now 5 for 10 raised to the power 3, then 3. See, again I do not have 10 raised to the power 1, so I'll fill again a 0 here and then 2 at the end. Now this first digit is 3, and then 1, 2, 3, 4 places. I do not have 10 raised to the power 3. So I'll place a 0, then 7, then again a 0, and then 5. Last one, 9, and then 1, 2, 3, 4, 5 places. I do not have 4. I do not have 10 raised to the power 3. I have 10 raised to the power 2. I have 10 raised to the power 1 also, but I do not have 10 raised to the power 0. So this is the short form. Okay, now writing these in standard form. You are given the numbers in the general short form, but not the standard form. Standard form is what you will do. Let's have a look at the first question. 5, and how many zeros are there? 1, 2, 3, 4, 5, 6, 7. Okay, so 1, 2, 3, 4, 5, 6, 7. Remember, you need to have your first number as it is. Now, since all the numbers are zeros, you do not have to put a decimal, because you know that if you put a decimal, it will be 0, or just write it as 5.0. You don't have to do anything. Times how many zeros are there? 7, right? So first one is this. Now second is now 7, and then 6 zeros afterwards. 1, 2, 3, 4, 5, 6. Here also we can directly write it as 7 times 10 raised to the power 6. Third is quite a big number, so I'm just writing it directly. So I will write it as 1.1865. We know that there is no value of the zeros after the decimal point. Okay, so we will not place all those zeros. We'll just see how many places were there after the after the decimal there would be in the question. So we can see 1, 2, 3, 4, 5, 6, 7, 8, and 9. So 10 raised to the power 9. Fourth question is 390878. This will be 3.90878. And how many decimal places we have? 1, 2, 3, 4, 5. So 5 zeros in the power. Next is 39087.8. No issue with the decimal which is in the question. We will place the decimal where we want it to be and just count the decimal places overall. 1, 2, 3, 4, 5. 5 again. The last question, 6. 3908.78. Again, the current place of decimal does not should not bother us. We have to place the decimal after the first number, after the first digit, and then count overall decimal places, which is again 5 in this question. Okay, so this is our standard form. And okay, now these are some word problems, so you have to just write these in the standard form again. So the questions are easy. Let's do it together. 1, 2, 3, 4, 5, 6, 7, 8. It is so 10 raised to the power 8. Now this is 3 times, count the number of zeros, again 8. Okay, you have to write the units in this because these questions are based on the some statements. So it is 1.2756 times 1, 2, 3, 4, 5, 6, 7. 10 raised to the power 7 meters. Next is 1.4 times how many places after 1? 1, 2, 3, 4, 5, 6, 7, 8, 9. Next is 1 times how many zeros? 11. Okay. Now it is 1.2. Count the places after 1. 1, 3, 3, 6, 9, 10. Oh, that's quite a big number. Do you see how huge these numbers are? So like writing them is going to be very boring. So it is 20. Oh my God. This is 6.023 and count the places after 6. 3, 6, 9, 12, 15, 18, 21, 22. Huge. Now this is 1.353 times 10 raised to the power how many? 9. And the last is 1.027 times 9. Again 10 raised to the power 9. So this is it. This was the last question. And we have finished the 11th chapter. Do post your queries, or if you have any questions, let me know. That's it from my side. Thank you.